Look around the universe, and almost everything seems to be spinning. Earth rotates. Planets orbit stars. Stars move around galaxies. Even black holes can spin at incredible speeds. But why? Why does the universe contain so much rotation? The answer begins billions of years ago, with one of the simplest laws in physics. Right now, even if you're sitting completely still, you're moving. Earth rotates once roughly every 24 hours. At the equator, the surface moves at about 1,670 kilometers per hour. But that's only the beginning. Earth is also traveling around the Sun at nearly 107,000 kilometers per hour. And the Sun itself is moving through the Milky Way. There is no truly stationary place beneath our feet. Our planet is part of several enormous motions happening at the same time. Rotation isn't something unusual in space. It's one of the most common behaviors we see throughout the universe. Earth isn't special. Almost every major planet in our solar system rotates. And together, the planets orbit the Sun in roughly the same direction and nearly the same plane. That isn't a coincidence. About 4.6 billion years ago, the solar system began as an enormous cloud of gas and dust. As gravity pulled that material together, the cloud's small initial rotation became increasingly important. Eventually, it flattened into a rotating disk. The Sun formed near the center. The planets formed from material inside that same disk. Their motion today still carries the memory of how our solar system was born. Now increase the scale. Our Sun doesn't remain stationary either. It orbits the center of the Milky Way at roughly 800,000 kilometers per hour. Even at that incredible speed, one complete orbit takes around 230 million years. The last time the Sun was approximately at this point in its galactic journey, dinosaurs had not yet appeared on Earth. And the Sun is only one of hundreds of billions of stars moving through the Milky Way. From planets around stars to stars around galaxies, rotation continues across increasingly enormous scales. The pattern seems almost universal. Moons orbit planets. Planets orbit stars. Stars orbit galaxies. Some neutron stars rotate hundreds of times every second. And black holes can spin at extraordinary rates. So where did all this rotation come from? There isn't a giant force continuously turning everything in space. Instead, the explanation comes from how cosmic objects form, and from a fundamental principle called conservation of angular momentum. It's the same physics that makes a spinning ice skater rotate faster when pulling their arms inward. And on cosmic scales, that simple rule helps explain why the universe is filled with spinning worlds, stars, and galaxies. To understand cosmic rotation, we have to return to the beginning. Imagine an enormous cloud of gas and dust floating through space. It may look motionless, but its particles are moving in countless directions. Nearby gravity, turbulence, and tiny differences in density create small amounts of rotation. The cloud doesn't need to start with a dramatic spin. Even an extremely small amount is enough. Because once gravity begins pulling the cloud inward, something remarkable happens. That tiny rotation can become much faster. The key is angular momentum. In a closed system, angular momentum is conserved. A familiar example is a spinning ice skater. With their arms extended, they rotate slowly. Pull those arms inward, and they spin much faster. A collapsing cloud behaves in a similar way. As gravity pulls material closer to the center, the cloud's rotation speeds up. Nothing needs to keep pushing it. The spin is preserved as the system becomes smaller. This simple principle operates everywhere, from forming planets to collapsing stars. As the cloud collapses and spins faster, collisions between particles begin changing its shape. Material moving above and below the main rotation plane repeatedly collides and loses some of that motion. Gradually, the cloud becomes flatter. A disk forms. This is why young stars are often surrounded by protoplanetary disks. It's also why many galaxies develop flattened structures. Gravity pulls material inward, while angular momentum prevents everything from falling directly into the center. The result is one of the most familiar shapes in astronomy, a rotating cosmic disk. Sometimes, this process reaches extraordinary extremes. When a massive star collapses into a neutron star, its core becomes incredibly small, but its angular momentum remains. The result can be an object only about the size of a city, rotating hundreds of times every second. Black holes can also inherit enormous angular momentum from the matter and stars that form them. So the fastest spinning objects in the universe aren't being constantly powered by some mysterious cosmic motor. Their rotation is a record, a surviving memory of everything that happened while they formed. The same principle extends to entire galaxies. Early in cosmic history, gravity pulled enormous regions of gas and dark matter together. These regions were never perfectly uniform. Interactions with surrounding matter gave them small amounts of angular momentum. As galaxies formed, that motion became organized into rotation. But not every galaxy spins in exactly the same way. Some are beautiful rotating disks. Others have stars moving along much more chaotic paths. Rotation is common throughout the universe, but nature doesn't follow one simple pattern. At the opposite extreme, some objects rotate almost unimaginably fast. Certain millisecond pulsars can spin hundreds of times every second. One of the fastest known rotates more than 700 times per second. Imagine an object with more mass than the Sun, compressed into a sphere roughly the size of a city, completing hundreds of rotations in a single second. Black holes can also rotate extremely rapidly. Near them, rotation becomes so powerful that it actually drags the fabric of space-time around with it, a phenomenon known as frame dragging. But this leads to a much bigger question. Planets spin, stars spin, and galaxies spin. Could the entire universe be rotating? So far, there is no convincing evidence that it is. On the largest scales, observations show the universe is remarkably uniform in every direction. Galaxies also don't all rotate the same way. Their spin axes point in many different directions. Scientists continue testing whether extremely subtle large-scale rotation could exist. But our best cosmological models don't require it. The objects inside the universe rotate. That doesn't mean the universe itself does. So why does the universe seem unable to stop spinning? Because rotation preserves history. Earth's spin carries information from the formation of the solar system. The sun's motion reflects the birth of the Milky Way. A pulsar's incredible rotation reveals the collapse of a massive star. And the spin of a black hole remembers the matter that helped create it. Angular momentum can survive for billions of years. So when we watch something rotating in space, we aren't simply watching motion. We're seeing a physical memory of how the universe became what it is today.